Welcome to ClickMyProject.com, a set of complexity measures designed for applying meta-learning to instance selection. Now we discuss about abstract. In recent years, some authors have approached their instance selections problem from a meta-learning perspective. In their work, they try to find relationship between the performance of some methods from this field and the values of some data complexity measures, with the aim of determining the best performing methods given a dataset, using only the values of the measures compute on this data. Nevertheless, most of the data complexity measures existing in the literature were not conceived for this purpose, and the feasibility of their use in this field is yet to be determined. In this paper, we receive the determinants of some measures that we presented in a previous work that were designed for meta-learning based instance selection. Also, we assess them in an experimental study involving their set of measures, 59 databases, 16 instance selection methods, 2 classifiers, and 8 regression learning used as meta-learners. The result suggests that our measures are more efficient and effective than those traditional used by researchers that have addressed the instance selection from a perspective based on meta-learning. Our proposal is the first set of C measures specifically designed for IS problem characterization. IS means instance selection. This means that for instance we paid attention to some aspects such as efficiency that have been out of the scope of other researchers dealing with C measures. There is another aspect related to our C means that makes that very suitable in the IS context. Several data sets created during their computation may be used later in the IS selections. So IS is an instance selection. This is find the our projects. Now we discuss about flow diagram. First we choosing the dataset. That dataset is uploading the databases and then find the overlap values. The overlap value is based on find the attributes values. The attributes values is giving the some values. That value is compared with the similarities. The similarity is give the some values. That values is using the tree construction process. The tree construction process is giving shortest node, longest node, and then find the eliminate edges. The eliminate edges means longest node is eliminated, and then find the mean values. The mean values is find based on the tree construction process. That mean values is using the clustering process. The clustering process is divided in two parts, cluster 1 and cluster 2. The cluster 1 is more than best values. The cluster 2 is worst values. The cluster 1 is again check the instance selections. The instance selection is the best values for data set. Let me see the demo. First we click home page and then right click. This is home page for set of complexity measures designed for applying meta learning to instance selection. So this is file choosing frame. So first we choosing the browse and then using the dataset. Click the dataset. So this is a database, dataset name. This is dataset path, and then this is the dataset values, and then click next button. Now we upload the data. So this select the dataset. Now uploading. So dataset uploading successful, and then next. So we find the overlap values. So first we choosing the main of s. So main of s is values is 0, 9, 1 contain, and then 0 value is count the 42, 9 values count the 147, and 1 is 60. So this is all the values. So you check the another attribute values. This is have 1, 2, 3, 4, 4, 10. So first we choose 1 is contain 60, and then 2 is contain 106, 10 is contain 29. So this is all values are we can visible. So 2, 106, so 7, 10. So I'm then choosing next frame. So find the mean values. The mean values is mean base. So find mean values. So this attributes have this mean values. So this attribute have different mean values. So each and attributes have different mean values, and then so that all attributes values. So here, and then choosing next. So classification process. So now we choosing one of us find the mean values. So this mean values using the classifications. So divide the classification process. The classifications are successfully completed. Then this is class 1, class 2. So you can see the different values using the different mean values. So now we choosing this attribute. These attributes give the some values. This mean values is based a classification process. The classification is different, and then give the some values changes. You can see that. So now we send next frame. So find the similarity values. So get the similarity attributes. So click. So this is the list of attribute values. This attribute values give similarities. So this is the result, the similarity values. So mean of checking the sum give values. So this is also the similarities. So see the next. So find the correlation classes. So choosing this is only check with class 1. So find the correlations values. This is also correlation values in class 1. Next checking the class 2 correlations. So this is also have the class 2 class. Next to find the using the spanning tree. The spanning tree is we have choosing. This is comparison with each attributes in again checking another attributes. So this is the cost rate. So next eliminating the edges. The eliminating edges means is more than values. So now we get the smallest values cost. See that only here. Next, and then these values are clustering in once again. So cluster. So this is cluster 1 and then cluster 2 classes. So this clusters using the instance selections. So find the features. This features values is this attributes. Okay, now we see the comparing graph. So compare time. So the execution time in second. Existing process get the time 20 seconds, but now proposed system is get the 5 seconds. It will be give some result. So compare instance selections. The instance selection is this is also get the 20 seconds execution system, but now proposed system is getting the something 8 or 9. Thank you. Thank you.